Now this time I'm going to skip down to question 4 on the sheet. Number 2 is the same as the one we've just done, question 1. Number 3 is very, very similar as well, except you're not given an angle, but you are given a distance out and a distance up, which means that you could nominate that angle theta, and you could find its cos and its tan pretty easily if you needed to. So I'm going to leave you do 2 and 3. Now I'm going to do number 4. Question 4 says, a uniform ladder of length 7 meters leans against a rough vertical wall at 45 degrees to the vertical. You're told that mu is a third, and it says there is rough contact with the ground, and mu is at half in that case. You've got to figure out how far up the ladder can a man of weight half that of the ladder climb before the ladder slips. Okay, so let's put all of that information into a diagram for a start. So we have a wall, a ground, we have a ladder leaning against that wall. Okay, the ladder is 7 meters long. It leans against a rough vertical wall at 45 degrees to the vertical. So this time I'm given an angle 45 degrees to the vertical. In the last questions, they were down, your angle was to the horizontal. It leans against this rough wall. So here's the wall, and it says the mu at the wall is a third. So we have friction acting here. If that ladder was to move or slip, it would slip down. So that means that friction is acting in an upwards direction. Okay, so I'll call that, and I'll say this reaction to the wall here, of course the normal reaction is in play. I'm going to call that N, which means that friction is equal to mu times N, and it tells me that mu is a third, so this is 1/3 of N. That's the first bit. There's rough contact with the ground as well, so there's friction acting over here. Again, that's going to act in the opposite the direction of motion, so it's that direction. I'll give it a different letter, I'll call it G. There's also a reaction to the ground, which I will call R. G is friction, so that means G is mu times R. And I'm told that on the ground, mu is a half, that's a half R. Okay, the other thing I need is the weight of the ladder, which I don't have. So if I'm not given a weight of a ladder, I'm going to nominate, I'm going to call it W. And it says that there's a man climbing up that ladder, and his weight is half that of the ladder. So I'll call his weight half W. Okay, so that's all the forces acting on my ladder now. That's my force diagram. Okay, this ladder it's not slipping, it's balanced. The other thing I have to find I'm going to draw a diagram now for distances. So I'm going to draw a distance diagram over here to see what's happening with the distance from the fulcrum. So again, I'm going to lean that ladder against the wall. I'm going to choose the base of the ladder, the default position for the fulcrum. And I'm going to have a look now at the positions of each line of action from the fulcrum. So here's the R force right through the fulcrum, the G force right through the fulcrum. Here's the W force. Okay, there it is, from there to there. I've got to find this distance here. I'm told the angle to the vertical is 45, and of course by the corresponding rule here this is also 45. So if I just remove this little triangle from here just to see what's going on, this angle here is 45. The ladder's 7 meters long, the weight force will act halfway along that, so this is 3.5. Okay, so I want to find this distance here from there to there. So that means that that distance, there's the angle, this is the opposite to the angle, that's the hypotenuse. So this will be 3.5, the sine of 45. Now here's the man, he's a half W along or his weight's a half W, he's this far from the ladder, look, from the fulcrum. That position there, because I don't know how far up the ladder he's gone. I have no idea. So I'm going to call this, his distance here, how far he's gone up the ladder, which I don't know. I'm going to call that distance from here to here X. So that's how far he's gone up that ladder. Okay, so now I'm just going to draw a little triangle again, remove that to see what's happening with him. He's gone X meters up the ladder. This is 45 degrees. And this is his distance from the fulcrum. The distance has to be the perpendicular distance from the fulcrum. So in this particular case, this is going to be, of course, again, this is the opposite side. It will be X by the sine of 45. Okay, so look at that. Make sure you understand where that came from. Okay, the next line of action is my friction here. There it is. So it's acting a distance from there to there. So if I were to just take this out again. So that's the whole length of the ladder, of course, which is 7. This is my angle again, which is 45. So the distance from there to there will be 7 sine 45. Okay, so that's those three distances sorted. Now let's have a look at N. We haven't done N yet. So here's N's line of action. There it is. So look at its distance from the fulcrum is from there to there, which is the same as from here to here. So that is the full black triangle there, that one. So that triangle, that full black triangle, that again is 45 degrees here. It's 7 meters long. And this is the side I'm after now, this bit. And that's the adjacent side. So of course that is going to become 7 times the cos of 45. Okay? Nearly there. It's balanced, this ladder. So if it's balanced, the up and down forces should be equal and the left and right forces should be equal. Right, so I've got up forces R plus 1/3 N equals W plus a half W. The left and right forces must be equal. So that means that the left, coming from the left force is a half R. That must be equal to the one from the right, which is N. Okay, I'm going to work with this now. And I'm going to put that, sub that into here. And that'll give me a couple of bits of information. So R plus, I'm using this equation here, 1/3 N. But N is now a half R, so I'll put in a half R here, is equal to W plus a half W is 1.5 W, so that's 3/2 W. So this is R plus 1/6 of R is equal to 3/2 W. That means that 7/6 R is equal to 3/2 W. So R is equal to 3/2 by 6/7 W. And cancel that down and I'll get, that'll go in 3 times, 3 3s are 9/7 W. Which means that N is a half of R. So a half of 9/7 will give me 9/14 W. Okay, so I have those bits of information now. So next thing I'm going to do is I'm going to have a look at the direction for the clockwise and the anti-clockwise. So again, same thing as before. Place a pencil down on the sheet, hold it at the fulcrum and see what forces will make it move in an anti-clockwise direction. So to make it move in an anti-clockwise direction, I push it up with forces coming from the right. So up from the right must be equal to, if it's balanced, all those moments are equal. So to make it, if it's balanced, those anti-clockwise moments must be equal to the clockwise moments. The clockwise moments are the ones bringing it down from the left. Down from the left. So I'm putting that down from the left. Okay, so what I'm going to do now is I'm going to apply those up from the right forces and the down from the left forces. Okay. So up from the right equals down from the left. Up from the right equals down from the left. Now the forces up from the right were the R force, the 1/3 N force and the N force. The ones that were coming down from the left was the W force, the half W force and the half R force. So let's just make sure we know that. Can we see that? Up is R, 1/3 N for friction, and from the right is the N force. Down is W, a half W, and from the left is this G force, which is the half R. Okay, I'm going to put in the distances now, which I've worked out, so I know what they are. So the R1 is going right through the fulcrum, that's going to be 0. The 1/3 N is 7 sine 45. 7 sine 45. The N is 7 cos 45. The half W is, or the W is 3.5 sine 45. The half W is X times sine 45, and the half R, of course, is W. So those distances, remember on that sheet now, match these distances that we found earlier. Okay, now we're just going to work that out. So this is going to become 7/3 N times, now the sine of 45 is 1/√2, plus 7N by the cos of 45, which is also 1/√2, equals 3.5 W by the sine of 45, which is 1/√2, plus a half W by X, and the sine of 45 is 1/√2. Okay, I just continue working down here, start cancelling things out. So this becomes, we know what N is, remember, N is 9/14W. So this becomes, all those 1/√2s will cancel. I'll get rid of all of those. So 7/3 by N, which is 9/14W, plus 7 times N, N is 9/14W, is equal to 3.5W plus a half W times X. Those W's will go all the way across. I'll cancel this one down. This will become, that'll go in 3 times 3/2 plus, this will become 9/2 equals 3.5 plus a half X. And when I bring over that 3.5, that becomes 2.5 equals a half X. So X equals 5. So that man can only go 5 meters up the ladder before slipping will occur.